Bismillahirrahmanirrahim. Assalamu alaikum, dear students. My name is Ehsan Elahi. I'm here with a new video which is about FET field fact transistor. We will discuss or study about field fact transistor today. Basically, we have studied earlier about BJT bipolar junction transistor, and we will study about field fact transistor today. Field fact transistor is a also three terminal device. Field fact transistor is a semiconductor device which depends for its operation on the control of current by an electric field. In BJT, we mostly use base current, but here we control field fact transistor by an electric field. And these are the some similarities of FETs and BJTs. We can see that BJT is also three terminal device here which is controlled by base current, and here is a base we apply the value of current to control the BJT, and it's a three terminal device, and FET also is a three terminal device. FET is controlled by gate to source voltage, and here is the formula. Here IC is a function of IB, which shows that collector current is controlled by base current, and here is the formula for function of FET, which is based on drain to source current depends upon drain to source. Here is a drain to source current depends upon gate to source voltage, and these are the similarities. BJT also used as amplifier, and FET as also used as amplifier to enhance the voltage or current, or to amplify the value of current and voltage. These are used as amplifier, and both used as switching devices to use as a switch, and these are switching devices. And BJT having low value of on-off ratio, but FT has a higher value of on-off ratio, about 10 raised to power 4 or 10 raised to power 5. It's the initial value of on-off ratio. And these are the some differences for FETs and BJTs. FET is a unipolar device in which at a time electrons or holes take part for conduction. But if we talk about bipolar junction device, in which electrons or holes take part for conduction at a time. FET is a voltage controlled device we have discussed earlier, and BJT is a current controlled device. And FET has high input impedance in mega ohm. That's why it's the best amplifier. It is used for amplification of voltage or current. And the value of BJT is the value of input impedance for BJT is low. And if we talk about the thermal stability of FET, FET is more stable thermally, and it can work as higher temperature, but the value or thermal stability of BJT is so low, and it has high switching speeds because it has high on-off ratio, about 10 raised power 4 or 10 raised power 5 at initial stage, and we can enhance the value of on-off ratio or switching speed by uh, doping or another processes we will discuss in later. And if we talk about the value of BJT, is it has low switching speed because it has low on-off ratio, and FET is less noisy during the operation or during the function. It uh, create low noise, or it produce lower value of distortion, and FT produce and BJT is a more noisy device, and it's easy to fabricate. We will study about fabrication techniques after some time in coming lectures. And this is the chart which tells about the classification of field effect transistor. This is the main FET and it has two main types, which is JFET junction field effect transistor and other is MOSFET metal oxide semiconductor field effect transistor. It has also two types. JFET has two types, which is N channel in which electron take part for uh, conduction and it's also p channel, it having a type which is p channel in which holes take part for conduction. And if we talk about the MOSFET, it has two types. It's a depletion type in which channel material is present, and it's an enhancement type which in which channel material is absent. It also has in depletion type we use some kind of semiconductor material or transition metal dichalcogenides as a channel material for switching the for switching. And it depletion type also has two types, p channel and n channel, and enhancement type also has the n channel and p type. We will discuss in future about depletion type, enhancement type, and difference and their differences, and we will study in detail their operation and functioning in future. And these are the p-type and n-type FT's differences. In n-type, current carriers are electrons, and in p-channel FET, current carriers are holes. Electrons having negative charge and current carriers are holes that they are positive charge carrier. And mostly we use n-channel material or n-channel FET. Mobility of electrons for n channel is high than holes, and mobility of electron is almost twice that of holes in p channel FET, and mobility of holes in FET is so poor, and it has low input noise and it has more noise. But if we talk about the stability, p channel FETs are more stable, but if we talk about mobility wise, the value of mobility in n channel material is more than p channel material. And mobility is if we talk about mobility, what is mobility? It's the number of charge carriers that travel from one point to another point, and it has n channel material having large conductance. And if we talk about what is transconductance, because n channel material has large conductance. And if we talk about the transconductance, the transconductance of a transistor reflects how much a transistor can produce current with the application of input voltage across its gates. And it tells you how much strong it is to convert a small amount of voltage into desirable current. It basically it's measurement of current on the basis of voltage. And basically if we talk about the transconductance in FET, for an FET, transconductance is the ratio of charge in the drain current to the change in the gate voltage over a defined interval. Basically it is the ratio of source drain current to the change in gate voltage that we have applied during the functioning. And this is the transconductance. And if we talk about the types of J-type, JFET junction field effect transistor, and it has two types, which is one is N channel and second is P channel. Here is N channel JFET in which the main material is here is N channel, and in on the sides p channel material is used. And if we short this p to this p type material, and which act as a gate in this procedure. And here is a drain and two terminals, and here is a source. We apply biasing to the source and gate to the gate source voltage we applied. And here is a p channel uh, device or p channel JFET. And we use n channel material for our operation. And This is the symbolic representation of JFET. Here is a gate, and here D is a drain, and here is a source. It is three terminal device, and here inward arrow shows it's an n channel material, and in second we can see that arrowhead outward shows the p channel JFET, and these are the symbolic representation of p channel and n channel device. And these are the two types of MOSFET we have discussed earlier, depletion type and enhancement type. And we can see here is it's a depletion type, D MOSFET. We can say them D MOSFET. It's a three terminal device. Here it's a schematic diagram of FT based on MOT2 channel, and in here we can see that this is the channel material we can use for switching, and these are the source and drain, and these are the metal contacts that they are placed or attached with the chrome, and this is the silicon oxide layer, and whole arrangement is placed on silicon substrate. This is a bottom gate through which we can apply uh, voltage, and we the whole representation shows the MOSFET, which is D type, depletion type MOSFET, and here we can see the symbolic representation of metal oxide semiconductor field effect transistor, in which here is the drain, and we can see the drain, source and gate, and whole arrangement is placed on substrate, which is also another terminal. If we short this substrate to source, when we then we can see the three terminal device, and this symbolic representation is uh, about MOSFET, which is D-type MOSFET. And here is another form of transistor, which is E-MOSFET or enhancement type MOSFET, in which channel material is physically absent or not present, and the charge carriers virtually make the channel material due to the biasing here, that we biasing applied to source to drain and gate to source, and it is also controlled by VGS gate to source terminals. And this is also schematic diagram of E MOSFET, and this is symbolic representation of enhancement mode field effect transistor. And we will study or we will discuss in detail their functioning in future or in coming lectures. And here is the main basic principle of FET. Either we use JFET or either we use MOSFET. And the operation of FET can be compared to the water flow through a flexible pipe. Here is the outlet which acts as a drain, and here is the inlet which acts as a source, and this place act as a control or gate. When the pipe is pressed at one end, water flows decreases, and we can attach this performance or this functioning of FET with this schematic diagram, and we can control the flow of water through stopper, and we can control the flow of electrons or holes or charge carriers through this gate. And here is a here source of as source of electrons or holes, and here is a gate which can stop or close the flow of charge carriers. And this is the main principle. This schematic shows the principle of FET, and the charge carrier travels from source to drain. And here is the best example to understand the working or functioning of FT. And this is the end of lectures today, and I hope you have understand this lecture, and we will discuss in future more about this.